Hello students, good evening everyone. So let us try to work out few more numericals related to this microscopes part, compound microscope. Right. So I think already we have discussed about the question number 72 in page number 182. Page number 182. 72 is done. Next, let us see question number 73. Question number 73, page number 182. Sorry, 183. 183. So what is given here in the question is, if the focal lengths of objective and eye lens of a microscope are 1.2 centimeters and 3 centimeters respectively, and the object is put at 1.25 centimeters away from the objective lens, and the final image is formed at infinity, then magnifying power of the microscope is. So what you can do here is, right, see here guys. So what is given here? If the focal length of objective and eye lens, objective is FO and eye lens is FE. FO is 1.2 centimeters and FE is 3 centimeters respectively, and the object is put at 1.25 centimeters away from objective. So if you compound microscope, let us try to take the brief representation of ray diagram. Let us say this is our objective lens, small lens, and eye lens, a larger lens with a larger focal length. Okay, so it is having focal length f no FO, and this is having focal length FE, and an object is put at 1.5 centimeters away from objective. This is objective from here. An object O is put at 1 point at a distance of let us say at a distance of this distance. Let us take it as object distance from objective is UO. So UO is equal to 1.25 centimeters away from objective lens, and the final image is formed at infinity. Final image due to eyepiece will be formed at infinity, means image distance due to eyepiece will be taken as infinity. Then magnifying power of the microscope. What will be the magnifying power of the microscope? You have to remember directly the relation so that you can use as a quick a formula or shortcut formula. So and you can get the answer little quickly than the conventional way of doing it. So we know magnifying power when the final image is forming at infinity. Final image is forming at infinity means, so you can say it is forming at normal position or relaxed position. In such case, magnification power can be expressed as m is equal to, of course, m naught into me, m naught into me, where m naught will be equal to v naught by u naught into me will be 1 plus d by fe. If it is forming, if the final image is forming at infinity, me will be 1 plus d by fe. If it is forming at sorry, at infinity, right? So if it is forming at a least distance of distinct vision, then it will be this. So in this case, it should be, yeah, when the final image is forming at infinity, then magnification of eyepiece will be d by fe, not 1 plus d by fe, or just d by fe. So here it is given if u naught is given, UO object distance from object is given, FE is given, D you can know this is least distance of distinct vision should be D is equal to 25 centimeters. You have to remember that. But V naught is not given. If you know that, this directly can substitute and you can find it out. But you don't know what is V naught. To find V naught, you have to make use of the lens equation. You have to make use of the lens equation. From lens equation, we know that 1 by f is equal to, for what is b naught you want, so for objective you have to apply lens equation. F 1 by f naught is equal to 1 by v naught minus 1 by u naught, right? As v naught, let us write this as 1 by v naught is equal to 1 by f naught. This 1 by minus 1 by u naught, if it goes here it becomes plus 1 by u naught. Now if you substitute these values with sign, f naught is uh, plus 1.2 centimeters. It is a convex lens, converging lens, so it is a positive focal length. It will be having positive focal length. And u naught, objective distance for objective, will be at the left side. So to measure it, you have to travel in opposite direction to the incident light. So it will be negative. So minus 1 by 1.25. U naught is 1.25 minus 1 by 1.25. On simplifying this, we get 1.25 minus 1.2 gives you 0.05 divided by 1.2 into 1.25. This further can be expressed as a 5 by 125 into 1.2. This gives you 1 by 30. On simplifying this, we get 1 by 30, guys. 1 by 30. So that is 1 by V naught equal to 1 by 30, or V naught is equal to 30 centimeters. What you want actually, you want magnifying power, this. So here we don't know v naught, that's why we are doing all these calculations. Once you know v naught, substitute all these values, other parameters are known, substitute here, then we get m. So let us consider here, this implies m is equal to v naught by u naught into d by fe, where v naught is 30, u naught is 1.25 into d should be 25, and fe is, what is fe? Fe is 3. Fe is 3. So you can cancel this as, and you can make it as 10 times it goes. Here this you can also write it as how many times it goes? 25, 0 0.5, 0.5. So is 0.5 only? Yeah, 0.5. Now 0.5 is 1 by 2. Is it 0.5 or 0.05? 0.05, guys. 0.05, yeah, 0.05. So if you but you know 1 by 5.5 is 1 by 2, but 0.505 can be expressed as, or how can you do this? 100 in numerator and denominator, if you multiply 100 by 100, it becomes 10 into 100 by 5. This cancels and becomes this 10 by 5 becomes 2, 2 into 100 becomes 200. 200. So this implies magnification of this compound microscope is nothing but 200. Is there any such option? 273? Right, that's it. That's the correct one. So not done this calculations, you guys try by yourself how to simplify quickly, that just you have to understand. Here also in this calculations, how can you do this? 0.05 by 1.2 into 1.25, how can you do this is 0.05 by 1.2 into 1.25, you do like this, into 100 by 100 you multiply, then what you will get? 0.05 becomes 5 divided by, this is 1.2 into 1.25 into 100 becomes 125. So 5, how many times it goes? 5 5 twos 10, and 5 fives 25. 5 25 is 125. Now 25 into 1.2 is 30, so that you should able to calculate, and you can write it as 1 by 30. So here you'll get this is equal to 1 by 30. Then 1 by v not equal to 1 by 30, and hence v not equal to 30. Again similarly here also, just first only if you have multiplied with both numerator and denominator with 100 by 100, you should have got this is 10 into 2500 by 125. 25 fives it gets cancelled, then you get 200. This way also you can get it. Okay, so this is while simplification, how to do little quickly also you have to develop that. So that will give you the timing. Timing is very important. Okay, so who can do quickly, those will be ahead. How can you do quickly? Based on practice. You need more and more practice, more and more practice. Yes, with concept and more practice. Concept, more practice. You will be ahead and you can compete anyone. Yes, that is the main mantra of competitive exams. You have to keep in mind. Next, question number 74. 74. So what is given here? Uh, Page number 183. 73 is done. 74. Let us see here. It is given that the question is the focal lengths of objective and eyepiece of a compound microscope are 1 centimeter and 5 centimeters respectively. Right. So let us note down this. Why very less number at there? Okay, Nana. Okay, fine. Yeah. It is go through this if you want. Next. Let us see. Next one. Question number 74. Right. 74. What is given here is the focal lengths of objective and eyepiece of a compound microscope are. Yes, guys. Focal lengths of objective and eyepiece. Objective FO, eyepiece FE are given by FO is 1 centimeter and that of eyepiece is 5 centimeters. 1 centimeter and 5 centimeters respectively. An object is placed. An object is placed at a distance of 1.1 centimeter from objective. That means object distance from objective is 1.1 centimeters from the objective, has a final image formed at least distance of distinct vision. Final image due to eyepiece is forming at least distance of distinct vision. Okay. Then magnifying power is what? Magnifying power is what? Simply just again the same formula I have to recollect back. When the final image is forming at least distance of distinct vision, we call it as a strained position. At infinity means relaxed position. Least distance of distinct vision position is called strained position. So in this position, magnifying power can be expressed as magnification of objective into magnification of eyepiece. Magnification of objective will be V naught by U naught only, but magnification of eyepiece under strained condition is 1 plus D by Fe. Under relaxed position is D by Fe. Under strained condition is it is 1 plus D by Fe. You have to remember this, guys. You have to remember everyone. Right. Now here U naught is given. Okay. D will be known. This is equal to 25 centimeters. Here this R directly can take here D directly. It is 25 and Fe is also given. V naught you don't know. Again here also you have to find out V naught by using the same procedure. So how to find that? 1 by F naught is equal to 1 by V naught minus 1 by U naught. From this you have to say 1 by V naught is equal to 1 by F naught plus 1 by U naught. With proper sign conventions, if you substitute, it will become 1 by F naught is 1. U naught is 1.1, but it is negative. This is U naught, it is negative, so it is minus 1 by 1.1. So on simplifying further, you can write it as 1.1 minus 1 is 0.1 by 1 into 1.1 is 1.1. So this can be expressed as 1 by 11. What is this? 1 by V naught. As 1 by V naught is 1 by 11, from this you can write, what is this? V naught is 11, right? So V naught is equal to 11 centimeters. First part is done. Once you know V naught, all other parameters are known. By substituting and simplifying, you get M. So this implies M is equal to V naught is 11, U naught is 1.1 into 1 plus D. D should be 25, Fe is 5, and all are in centimeters only. So on simplifying this, we get 5 fives, 25. Then 1 plus 5 is 6. So this further can be expressed as 11 by 1.1. So to remove this decimal, let us multiply both numerator and denominator with 10. 10 by 10. So we'll get 110 by 11 into 1 plus 5 is 6. So it gave, how many times it goes? 10 times. 10 into 60 is 6 is 60. So therefore M is equal to 60. M is equal to 60. Got it? Yes, this is how you have to just work on this kind of questions. Go through this once. Next. Next. So you have, only thing you have to remember is object magnification of object will be V naught by U naught only, but magnification of eyepiece will changes depending on the final image location. Final image is at a relaxed position, it will be just D by Fe. If it is at a strained position or at least distance of distinct vision, then it will become 1 plus D by Fe. That you have to take accordingly. Next, yes, is there any chats? Okay, Dinakaran, good evening, sir. Yes, good evening, guys. Karunya, Karunya Raja, good evening. Yes, guys, good evening. Uh, the remaining questions are also a similar kind of questions, but with a little modification, just additional points, with little additional points. That is, they are given by making use of one more point called a tube length, the tube of length of a microscope. Right. Let us see what is this and how to go ahead with this. Next question number 75. 75 and 76 are similar ones. If the final image is formed at infinity and final image is formed at least distance of distinct vision provided that the tube length is given, then how to find the object distance from the objective and distances of object and image from objective. How to find this? Let us try to understand. Question number 75, let us see first. 75. 183. Yes. Yes, guys, I may, yeah, let us see. After this, both are 75 and 76 are similar kind of ones. So, one I will do, the other one you guys try yourself. And level 2 exercise 1 questions. Yes, I think you have received, all of you have received already a message in the group that uh, you have holiday tomorrow, but I'm going to take a session. I'm going to take a class from 12 to 1, 12 to 1, or if possible, up to 1:30, 12 to 1 or 1:30. I will try to have a session. Okay, so that the remaining questions in this, specifically this, I would like to cover the concept of telescope. And if we'll try to work out that first, we'll try to concentrate, because you have got an idea of how to work out the questions based on microscope. Already simple microscope based questions we did already. Compound microscopes, just you got some idea now. Telescope part we'll see tomorrow itself, tomorrow. And we'll try to work out some questions as well, if possible. Again, in the after lunch session, we'll take one more session, and we can try to work out the remaining numericals. Otherwise, just we'll try to have 1.5 hour session from 12 to 1:30, or 1 o'clock. Okay, for 12 to 1 fixed, depending on the requirement, we'll try to stretch, or we can wind up, that we'll see. So 12 to 1 we'll be having a session tomorrow, guys. Keep that in mind. Tomorrow, 12 p.m. to 1 p.m. physics. We'll be having physics session. Okay, right. Now, so let us go ahead with this. What is this question number 75? What is given here is, a compound microscope has an objective of focal length 2 centimeters and eyepiece of focal length 6.25 centimeters. Objective and eyepiece of focal length 2 centimeter and 6.25 centimeter respectively, and these are separated by a distance of 15 centimeter. So if you have, let us, just for understanding purpose, let us try to have a pictorial representation. If you are having an objective and an eyepiece, a bigger lens with a larger focal length, objective and eyepiece, provided the distance between them will be called as a tube length, or tube of length, or tube length, or microscope length. It is denoted by L, which is equal to object distance of image distance of objective plus object distance of eyepiece. Usually we consider this one. This is given as 15 centimeters. 15 centimeters. If final image is formed at least distance of distinct vision, final image due to eyepiece is formed at least distance of distinct vision, this is equal to 25 centimeters. The distance of the object from objective, distance of object from objective UO is equal to, what is the question? Okay, you know objective focal length. If image distance is known, then by making use of this, and I can find out this by using lens equation. But you don't know V naught also. If you know UE, object distance for eyepiece, at least then you should have taken V naught is equal to 15 minus UE, that will give you V naught, and hence you can follow the same procedure. So here, how to proceed further, let us try to understand. Here, FE is known, V is known, then can you find UE, and hence then you can find V naught, and hence you can find out U naught is. Let us try in that way. So from lens equation, we can say 1 by F is equal to 1 by V minus 1 by U. For eyepiece, if you consider 1 by FE is equal to 1 by VE minus 1 by UE. Okay, so this can be expressed as 1 by UE want. So you take it here, it becomes a plus 1 by UE is equal to 1 by VE minus 1 by FE. Let us substitute the values with the sign convention VE. So for eyepiece, for eyepiece. So here incident light will be in this direction. We will be to measure. We have to come in the opposite direction. Final image will be formed in this direction. So it will be negative. So minus 1 by 25. Minus 1 by 25 minus focal length will be positive. So minus 1 by focal length of eyepiece is 6.25. 6.25. Simplify this and tell me what you will get. So it is equal to 25 into 6.25, and here minus 6.25 minus 25. So that means sum of these two values gives you what? Minus 6.25 minus 25. 31.25. 31.25. Yes. 25 plus 5, 30, 31.25. 31.25 negative value, minus. So 31.25 by this, what will you get? So can you write this further? Minus 31.25 divided by 25 into 6.25. 25 into 6 point. Otherwise, let us do other way. What will be this? 6.25. Wait. 31.25 divided by 6.25 divided by 6.25 is equal to 125. What is this? I think we have done from 31.25 divided by 31.25 divided by 6.25 is equal to exactly 5. So 5 times it goes. So 5 is 25. So minus 1 by 5. So no need to do what you call complex calculations here. Simply you can do it, right? So you get what? Minus 1 by 5 or 1 by 5. Minus 1 by 5. So you can say this implies U is equal to UE is equal to minus 5 centimeters. UE is minus 5 centimeters and magnitude is just 5 centimeters. So what is this? Object distance from eyepiece. Object distance from eyepiece. Object distance. UE. Somewhere here this will be U0. So the sum of these two is nothing but L. Now can you find V0? Let us say this is the one. Okay. So 1 implies I can say L is equal to this, or V0 plus UE is equal to 15. This implies V0 is equal to 15 minus UE. So it is equal to UE is equal to what? Minus 5. Only the value we want, numerical value. Then what you will get? 15 minus 5 is equal to, with sign we are getting, but numerical value is 5. So 15 minus 5 is 10 centimeters. So V0 is 10. V0, that is plus 10. That is the image distance for objective is plus 10. So in this direction we will get to the right side. So if the object is here, light is traveling like this, it will form the image somewhere here. So this is the image distance. To measure this, we are traveling in the same direction. Now if it is V0, you are supposed to find U0. You know F0, V0. Can you find U0? Yes, very simple, by using lens equation. Yes. Now to find U0, let us take 1 by F0 is equal to 1 by V0 minus 1 by U0. Again, you want U0, so let's bring this here, this side. Just like here, to find UE, you have brought this and taken and simplified, right? Same way, let us simplify here. 1 by U0, if it comes here, it becomes plus 1 by U0 is equal to 1 by V0 minus 1 by FO. With sign convention, if you substitute the values, V0 is what? V0 is 10 plus 10, 1 by 10 and minus focal length of object also positive, so its value is focal length of object is what? 2. So you can write it as minus 1 by 2. So it is 2 minus 10. 2 minus 10 is minus 8 by 2 into 10. So 2 fours. 4 by 10. 4 by 10 is what? 1 by f naught. Sorry, 1 by u naught. We are trying to find 1 by u naught, right? So this implies 1 by u naught is equal to minus 4 by 10, and this further implies u naught is equal to minus 10 by 4. So it is equal to 4 twos 8 and 4 fives 20. So 2.5 minus. So what is that? So question number 75. This implies u naught is equal to minus 2.5 centimeters. U minus says that object will be to the left. So without the sign, you can say its distance is 2.5 centimeters. Okay, that's it. So you can say only the value of this is equal to 2.5 centimeters. The sign says that it will lies to the left side of the lens, in opposite direction to the incident light. You have to measure that. That's the meaning of it. Okay, this is how you have to work it out. Step by step. So you should think first what to use, what is given, and what you are asked to find, and how to proceed that. How to proceed. Okay, guys. I think this has asked one question. Let us see this in the tomorrow's session. Tomorrow's session. Just now, I'm stopping the session. Just I have another session now. Okay. Tomorrow again we'll try to finish all the questions, especially level 2 questions. Every question will work out so that you guys can try the level 1 questions. Okay. Yes. Once again. Yes, Nana. Dinkaran. Okay, okay. So that is for the total magnification. We have to formulate to magnifying power of microscope. Magnifying power of microscope. Microscope is m is equal to, we have to formulate. Actually, it is equal to m naught into me, where m naught will be always same. So once at one time you can take it as v naught by u naught into d by fe, and sometimes we'll take this as m is equal to v naught by u naught, that is m naught into me will can be taken as 1 plus d by fe. So your question is when to use this and when to use this, right? This magnification usually we use when the final image is at infinity. When final image forms at infinity, then magnifying power is given by this. This can also be called as, that position is also called as relaxed position or relaxed position case. Relaxed position case or normal position case. Yes, yes. Infinity means relaxed position. This is called when the final image, this will be used when final image is formed at, when final image is formed at least distance of distinct vision, at least distance of distinct vision, that is d. This is also called as strained position. Strained. Why this is called strained position is, so if you are let us imagine that you are what do you call it? Try to think about only single lens. What do you call it? Simple microscope. Simple microscope is nothing but magnifying lens, right? To see something, let us say you are having a single lens and you are trying to view letters in your notebook or textbook, and you just, if you are trying to adjust this position, if you adjust the position in a relaxed position, it will be okay. But if you are using this lens and if you are adjusting so that if you want to see the bigger letters, you have to you have to move little to this position called a particular position, so that the final image should be formed at least distance of distinct vision. In such case, the as that condition will be called as a strained condition. That means in that case, your eye will feel little strain. Physically, your eye will feel little strain to see the maximum possible magnification. So we can say here, this magnification will be relatively larger than this magnification. So maximum magnification is possible when the final image is formed at least distance of distinct vision. But this also gives magnification, but there is relatively less magnification than this. So this is a relatively larger maximum magnification than this. So to get maximum possible magnification, the final image should be formed at least distance of distinct vision. That position can also be called as a strained position. So your eye will feel little strain in that position. Okay. Right. So this terminology you have to remember. When final image is formed at infinity, then or at relaxed position, then magnifying power or magnification of a microscope is given by this. When final image is formed at least distance of distinct vision or D or in the strained position, then magnifying power or magnification of the microscope is given by this. Remember that terminology. Okay. Okay, okay then take care. Just I'm stopping the session now. Well, tomorrow we'll be having from 12 to 1 the physics class. Okay. Okay, guys. Okay. Yeah. Okay, guys. Then I'm stopping the session.